This is going to be a video which shows how to cut a cam profile on a shaft, or in this case on a gear hub. There was already a profile, you can see the notch in the hub there. This was from a previous profile which I'm going to change. I'm going to basically take that notch out and put a new standard cam profile with a single lobe on this hub. And using a rotary head or a rotary table to rotate the work between plunge cuts, and a boring head cutting on the inside to make a sweep across the gear and remove material from the hub to form the lobe. I think this will become apparent as I move forward with the video. This is a small brass gear that's about 3/4 or maybe 3/4 to 5/8 of an inch in diameter. Here, I'll put my finger in here and you can kind of get an idea of the size of everything. This is my index finger right behind it. I'll zoom out here and show you sort of how the mechanism works. There you can see the entire rotary table and the dividing head, or the rotary table and the boring head. And as I rotate the boring head, you can see it sweeps out a long ways from the head on the far pass, and on the close pass it comes in and swings an arc close to the gear. See, I get it in pretty close here. You see it sweeps in and will take just a small piece of an arc off of there. The first step will be to make a plunge cut like this, taking it all the way to the bottom, and then back up. And then I'll move the milling table to the left, which will move the cutter into the hub more, and I'll repeat that, making plunge cuts until I get to what would be the minor diameter of the cam lobe. That is the part of the cam lobe where it's not activating the valve train. So let me switch this off, and the next part of the video we'll start cutting. So now I'm going to start cutting, and again this first series of cuts will be to nibble off one edge of the cam lobe until I get the cutter head into the minor diameter of the cam. So here we go. So here I've nibbled off a flat that at the middle would define the minor diameter of the cam lobe. Now I will start rotating the cam blank, small increments of an arc or a turn, and repeatedly plunge down. Each time the cutter is going to take a small sliver off of the leading edge or the protruding edge of the cam gear, and I will go most of the way around until I get to a point where I'm left with a single lobe on one side that defines the major diameter of the cam lobe. Before I do that, I have to hook up my electronic rotary table so I can begin the process of rotating in between cuts. So more to follow. Okay, I've got the rotary table all set up. I'm using an electronic rotary table that I built using an Arduino computer and a NEMA 23 stepper motor through a 72 to 1 reduction worm gear on the rotary table. This uses an infrared controller or a little hand remote that I can use to step the rotary table through its various steps. Here you can see what the remote looks like. It's pretty big in this blown up picture, but it's actually only about 1.5 inches by 2.5 inches, something like that. I've got the number of divisions that I'm going to step through at 60. That means I'll have to repeat this process 60 times. Each plunge cut, I'll rotate the table 1/60th of a turn, and hopefully that will be fine enough that I won't have a lot of faceting on the on the gear. I should mention, by the way, that I've got this dividing head set up. I've got the boring head set up to cut a circular pattern of about 1.5 inches. The bigger the circle, the flatter the lobe, the flatter the rise and fall on the lobe will be. The shorter the diameter of this circle, the more rounded it'll be. So it depends on whether you want a real sharp rise and fall of the valve or if you want a more gradual. And this one I would consider to be somewhere in the middle. So I'm going to go ahead and start. I'll be advancing the rotary table 1 division, pulling the head down, advancing, pulling, advancing, and cutting, and so forth until I get all the way around. I'll do a few steps and then I'll fast forward ahead to the end of the video. So here I'm going to advance the rotary table 1 turn, or 1/60th of a turn. And then I'll cut. Another 60th, plunge. You can see with each plunge, it's only cutting one side of the flat off. So I will pause the video here, and then I'll go most of the way around, and I'll pick it up when I get close to the end. All right, I'm near the end of this cut. I am having a bit of a lighting challenge here, so hopefully this will turn out okay. I'm going to go ahead and start up the milling machine again and do the remainder. Hopefully you can see the what's left of the lobe, cam lobe, right here on the front. And I'll be nibbling away from the left side of that as I finish up the cuts. I think that's about far enough. I've got about a 32nd of a little inch wide flat on there, and I'll just round that over, and that'll be that will be the lobe. Let me get that out of there and see if I can get a picture of it. So here you can see the mandrel that I've used. Let me zoom out a little bit here to see if I can make this a little more presentable. So here's the gear, and here's the let's see if I can get that cam lobe on there. All right, hopefully there you can see the profile of the cam lobe. And smooth it off with a file and it'll be ready to go.